Alright, so there's several different things that we need to discuss, and let's get into it. Notice all of these say a parallelogram. So basically we're under the title of parallelogram. So all the other stuff that we talked about is true with parallelograms. So let's review real quick a parallelogram. Well, a parallelogram, opposite sides are parallel, okay? Also, opposite sides are congruent in a parallelogram. Opposite angles are congruent in a parallelogram. Consecutive angles are supplementary in a parallelogram. Alright? These are all things that discuss a parallelogram. The diagonals bisect each other, cut into two equal parts, just each individual diagonal. These are the theorems and postulates of parallelograms. Now, a rhombus is a type of parallelogram with four congruent sides. So it's a little different. All sides are the same. A rectangle is a parallelogram with four right angles. And a square is a parallelogram with four congruent sides and four right angles. So what does that make square? It's both a rhombus and a rectangle. If you catch that, it has elements of both of those in there. And so that's going to be the challenge in this section, is making sure you understand the differences between the square and so on. So let's talk about a rhombus. A rhombus says a quadrilateral is a rhombus if and only if it has four congruent sides. All right? Rhombus usually has this little slant to it. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So the diagonals are perpendicular also. So you get that? The diagonals are perpendicular in the rhombus. So not only do they bisect one another, they're perpendicular. Alright, which means 90-degree angles, which is helpful because maybe sine, cosine, and tangent or Pythagorean theorem comes into play. Thinking forward. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So here's another issue here. The diagonals cut in half the opposite angles in a rhombus. In a rhombus, the opposite angles, like AC here, are cut into two equal parts because it's a rhombus. The diagonals cut them into two equal parts. So what does that mean? For example, if the whole angle A here was 100, that means this diagonal here, a segment AC, splits this angle A into 50 degrees and 50 degrees down here and 50 degrees and 50 degrees up here. But all that other stuff is still true. So that's just something to keep in mind about the diagonals of a rhombus. A quadrilateral is a rectangle. Now we're talking about rectangles. Now we're not on rhombus. A quadrilateral is a rectangle if and only if it has four right angles. Okay, so you got four right angles, you're talking about a rectangle. Alright? Again, we didn't know anything about the angles except that the bisector here splits the angles when you're talking about a rhombus. Now we get over here to quadrilateral, we see that it has to have four right angles. A rectangle has to have four right angles. A parallelogram is a rectangle if and only if its diagonals are congruent. So notice that the diagonals equal one another. Now that's not the same as a rhombus. A rhombus, the diagonals are perpendicular. Alright? Here, the diagonals are congruent. Alright? So notice that they still bisect one another. So DB equals, well, D, whatever that part, equals that part as well. All the actual little segments are congruent to one another. Alright. A square, a quadrilateral is a square if and only if it is a rhombus and a rectangle. So what we have here is all the properties that we spoke about a rectangle. Here, four right angles, congruent diagonals, and a rhombus, four congruent sides, perpendicular bisectors, bisecting opposite angles. Both rhombus and a rectangle, both is a square. So all the properties of both of those are found in a square. Alright? Okay, let's look at this little simple worksheet. Maybe it'll help us understand the differences between the two or the three. Okay? First of all, let's look at this. Rhombus. Rectangles, squares are special types of parallelograms. Yes, I heard you say it. You said parallelograms. I know you're getting it. A rhombus is a parallelogram having all, what's all in a rhombus? Well, all congruent sides. All sides are congruent in a rhombus. A rectangle is a parallelogram having all what? What's all the same in a rectangle? Right angles. All right angles. All right? And a square is a parallelogram having all congruent sides and all right angles. How a square is both? Notice that a square is both. All right. Now, I'm not going to be able to go through all this, but you can see where this is going. You got to check the box to see which one is always true. All angles are congruent. Will always be the same in a rectangle and a square. Not a rhombus. That's not true. All sides are congruent. Well, that's going to be a rhombus and a square all the time. All diagonals are congruent. That's a rectangle and a square. So I imagine that the square is going to get tagged on every single one of those because it's both a rhombus and a rectangle. These two are going to alternate as we would have moved down. Each figure is a parallelogram. Identify what special type it is. Okay, looking at this, you see that lean, that little slant? Is always an idea that you're dealing with a rhombus when you see that little lean and slant. Notice that the diagonals make a perpendicular angle right here. Automatically, you should be thinking rhombus. All right. Here, notice that I have those sides are congruent, which means the opposite sides are also congruent because it's a parallelogram, and it has a right angle. And so if this is a right angle, this is a right angle, and so on and so forth. So this has to be a square, right? Because all the sides are congruent, all right? And so you'll be able to use things that you've learned to answer questions. Now, here's a good chart to actually have. It's kind of letting you know a square is like both of these. This is what's called a Venn diagram. Hopefully y'all have seen that before. A square is actually both a rectangle and a rhombus, and it has both of the properties. But a rhombus is by itself and a rectangle is by itself. All right? All right, let's look at some algebra real quick. Let's look at this example. A, B, C, D is a rectangle. So we know it's a rectangle. We should know all the properties that go with the rectangle apply to this particular problem. So they give us a question here. They say if AC is 2x plus 13 and DB is 4x plus 1, find x. Okay, so AC is this diagonal here, and DB is this diagonal here. So what do we know about the diagonals of a rectangle? This is where you could use your notes. You can go back to your notes and you can say, well, a rectangle's diagonals are congruent. What does congruent mean? That means that they are equal. And so what we would do, let's see where you're at. What we would do is this. Well, I know it's hard for you to see, but it says AC is 2x plus 13. So what I would do is say 2x plus 13 equals 4x plus 1 because the diagonals are congruent. And I know that's kind of hard to see there, and I can't zoom it, never mind. So that's the idea, is I would solve for x, subtract 2x, subtract 1. So that'll be 12 equals 2x divided by 2, and x equals 6. All right, that's just an example of how you would use this particular rectangle property. Okay, here's an example dealing with rhombus. It says use rhombus below and the given information to find each measure. So they are telling us it's a rhombus. So I know what properties should apply. I don't have to guess because they're telling me. So number 4 says if angle PRS, so this angle right here, is 17. Find angle QRS. So what do we know about the angles of a rhombus? Well, if you don't remember, you go back to your notes and the angles come up here. Well, the only thing we know about the angles is that the diagonals bisect each angle of a rhombus, which is very important in this particular example as we look at it. Now, if this part is 17, since this RP bisects it, that means the whole thing has to be 17 right here and then 17 right here, which means this angle has to be 34 because it just simply cuts it in half. Angle 6, they want to know what angle STR is. Angle STR. Let's go back to our notes. Notice that these angles, these diagonals bisect. Not bisect, I'll get it right. Are perpendicular. I'm pointing at it, but I said the wrong thing. Are perpendicular. So that means all of these intersect and make a 90-degree angle. So how is that important? Well, when we look at this example here, STR has to be 90 as well. All right, let's look at number 5. If SP is 4x minus 3 and PQ is 18 plus x, find x. All right, so now we need to think about what do we know about the sides, SP and PQ. Okay, so we can go back to our notes, and the first thing it says is it has 4 congruent sides. So what does that mean in a rhombus? That all the sides are congruent or the same or equal. So if that's the case, then I can do this, if it'll act right. I can say that 4x minus 3 equals 18 minus x. And notice I didn't add them together and make it equal 180. I didn't make up something and decide that that's what I'm going to do. I let the notes, the rules, the theorems tell me how to set up my equation. And if I need to find x, you know, I just need to solve for x. And so over here you get 5x equals which is a decimal, like 4 1/5 or something like that, a fraction. 5x plus 3. Okay, so that's just an example of how to work, how we would use those. And remember, a square has both of those. All right, a square is both a rhombus and a rectangle. All right. So, in conclusion, today, all of these are parallelograms. All the rules for parallelograms we talked about here are still true with all of these. However, you can go a little bit further and talk about a rhombus, a rectangle, and a square. A rhombus, all congruent sides, perpendicular diagonals, and the diagonals bisect the opposite angles. A rectangle, all 4 90-degree angles and congruent diagonals. A square is both. All those properties apply for a rhombus and a rectangle to a square. That's all I got.